Welcome everyone, and thank you for joining today's session on IoT, edge computing, and everything in the event streaming and the communication space. Sorry, big mouthful there. Today with me, I have Waehner, our field CTO at Confluent. I've got Sohan Domingo as part of Tait Communications, and also Dion Stevenson, who's also part of Tait Communications. Thank you for joining everyone here. Now, before we kick it off, maybe if we want to get a quick overview, either by Sohan or Dion, as to what Tait Communications does, and I guess the field that you play in, we'll start from there.
Yeah, sure. So I'll start, and Dion is going to jump in and add, I'm sure, a fair bit about Tait. He's been a veteran in the organization more than I have. But to begin with, Tait Comms is a company that's been in the industry for around 55 years. And we serve customers in the public safety. When I say public safety, I mean the likes of police, fire, ambulance, fire services. So that's one vertical that we cater. The other one is mining. Mining customers are another customers of ours, utilities, and we have also oil and gas. What we do with these customers is sell mission critical infrastructure. Mission critical infrastructure involves land mobile radios. It's a very great term. When I say LMR, it includes DMR, digital mobile radio, and P25. So we supply mission critical voice solutions to our customers, and that involves the core network, the base stations, portable devices that you usually see on a mining field personnel's hand, or police, fire, and ambulance. They use portable radios for voice comms between the field and a control center. And we also supply applications to manage and monitor this network. We have a range of devices that we provide to our customers in the field. I just mentioned portable is one of them, UHF and VHF radios. Conventional and digital trunk phase 2 radios. Here in Australia, we are providers of portable radios to customers in ambulance, New South Wales Ambulance, and back at Queensland. Dispatch consoles is something that we provide to monitor and manage talk groups on the network. And we have mobile LMR devices that we offer our customers that can be installed inside vehicles that do a little bit of edge computing. And that's something that we are looking to go ahead to event streaming with the likes of Confluent. Maybe deploy Apache Kafka on that and do a bit of event streaming to our customers. But in general, we are a company that provides voice comms to our customers in public safety, mining, utilities, oil and gas. We are venturing into the application space. Some of the things that we are looking into is computer-aided dispatching application, and this is very much used in control center applications around the world. We have partner companies that provide CAD solutions. We're looking into artificial and machine learning algorithms that can enhance voice comms. When I say enhance, when you do push to talk on LMR, sometimes you have a lot of voice that could be a dog barking or anything else that can disturb the dispatch console from understanding what the field operator is trying to say. So we are venturing into using algorithms to suppress this voice and have crystal clear sound at the dispatch console. So in addition to the hardware that we supply, we are also getting into the applications such as the CAD, artificial intelligence, and machine learning. A few things that we have been doing recently is in the IoT space. Again, we have a huge partner ecosystem within Tait. So we don't shy away when it comes to partnering with top-notch companies out there, because we believe that by partnering with the right organizations around the world, we can provide a better service to our customers and better solution, and also come up with innovative solutions. And so IoT is another technology that we have ventured into for mining, agriculture, utilities, and public safety.
Yeah, fantastic. Thank you for that. That's amazing. I mean, you'd think that it's all about radios, and it's almost like, in my mind, something that's near like that is like a walkie-talkie. You don't really think that there's so many smarts and everything going behind it as well, but you guys are really venturing into that analytics field and delivering more to your customers there in that space as well. They're really becoming data-driven. So yeah, that's really good. Thank you for that overview there. Kai, do you want to give a quick overview of yourself there as well? I guess a little bit more about Confluent?
Yeah, sure. So at Confluent, we do process data in motion. This means we continuously connect to different systems, applications, and devices. That's our main idea, to continuously high volumes of data for analytics, but also transactional data. And this data is everywhere. And I think this is really important in this discussion. So we heard about the infrastructure and the networks we need. And with that, we also need to think about where we deploy the data processing. And this brings us to this discussion today, because when we think about IoT and edge, this is super important for industries like oil and gas and mining and so on. So let me maybe explain how we fit into that. So and it's also important to define these terms all the time, right? Because everybody thinks differently about it. So with IoT, typically my understanding is that it means that there's machines or devices, mobile phones, or something like vehicles that produce and consume events with sensors. And then you process it somewhere in real time and correlate it to other systems. And we can do that totally in the cloud. That's good for some use cases, but especially in the industries we just heard, like mining and oil and gas, actually, often you have to do the processing at the edge. So this is the second buzzword to define. So when I say edge, it really means we're talking about outside the cloud, outside of a normal data center. So this is where we have small pieces of hardware that are often lower footprint, but still often used for mission critical processing at the edge, for analytics, for monitoring, sometimes for compliance or even safety reasons in air-gapped environments. And therefore, I think for a starting point for this discussion, this is important to keep this in mind. You always need to think about where you need to do the data processing and how to integrate between the different edges, like in the oil and gas field, and then maybe also the central data center in the cloud, where you aggregate all the data from the edge. And this is really where we play the key role everywhere, because we can deploy event streaming at the edge in small hardware, for example, or we can also deploy it in the cloud, and we can even do this integration between all of that in real time at scale in a reliable way. And that's what I think is our kind of business in the IoT and edge space, so that we really do the processing of data in motion end to end, including the integration and data processing. And we are very flexible of how to and where to deploy that. But we're really this data hub. So we also work with other partners from a data analytics space, or also then from an infrastructure space, because that's what our partners do. That's not what we are doing.
Fantastic. Thank you for that explanation. You actually touched on the point I was going to ask you next. What really was edge and IoT? So you knocked that one up and took the words right out of my mouth there. So thank you for that. And so Dion, over to you there. I guess I can imagine in your space with communications, as you mentioned, connectivity is typically an issue as well there, right? Is this where you see edge computing play a big role in your field there as well? And I guess what's an overview of where you see it play a part there?
Yeah, that's a really good question. I guess Tait has been traditionally a voice sort of centric company, but as we've moved down the corridors of time, data is massive. So in the old days, it was good to have a radio. You could pick up a portable and talk and say, "Hey, I need help." Today, actually, what someone wants to know is context. What they need to know is where that person is. Where is the team around them? What a vehicle are they in? What's the capability on that vehicle? You know, what is their voice sounding like? Are we able to detect duress in their voice? Are we able to detect that, look, actually they're really distressed? And their vehicle, is it the right vehicle to send those that are near them? It's no point sending a fire engine if you need an ambulance. So those sorts of things are massive. And we see that getting that data back is absolutely critical. You know, we're in a increasingly heading into a converged world, and particularly in the New Zealand space, we have cities that are well catered for the LTE cell phone infrastructure. You move outside the cities and that infrastructure is less than reliable by a long shot. And so you need products that can have multi-bearer capability. They know when they've got the LTE stream, they can pump that data through, send it back. But when they head outside those central cities, actually, we still need data. We need a subset of the data, but we still want all the data at some point. But more importantly, voice at the end of the day, it's the last line of defense. I pick up my radio, I can talk back. So it gives us the significance is no matter where they are, what they're doing, we get communications happening from the edge. And if you're away from a central LTE system, having edge products that can make some core fundamental decisions based on workflows and productivity and those sorts of things, it is really important that we're able to do that at both ends to suit the needs of a modern workforce and in an emergency environment where people's lives are literally on the line at times. So that's where I see the significance of all of this product and all of these discussions heading for us.
Yeah, fantastic. That actually falls really well in line with some of the stuff that we hear at Confluent as well. Kai, I guess on the edge there, I mean, we hear a lot of stories about ML and AI, and this kind of really plays into that part there as well, right? With this type of use case there, that interconnectedness and AI and ML, making sure that people get the right data at the right time, right?
Mm.
Yeah, absolutely. I mean, the key point here is, as just we heard in the use cases Dion described. So it's about acting in real time. And if you think about this, most of the use cases in real-time data beats slow data. That's true almost everywhere in these cases. And there is then some scenarios in emergency where you just have to call a person quickly, right? So this is not AI. But in general, it's also about continuously monitoring all the data of the infrastructure so that you can alert a person, for example. So it's really critical to integrate and correlate all of that. And then maybe also based on some sensor input in real-time and aggregations, then you send a call to a person so that that person acts on the safety critical reasons. And in addition to that, it's also important to differentiate a little bit. So there is these super low latency use cases where you need to act very quickly when it's safety critical, for example. But in many cases, you also want to use the data further for other use cases, for later analytics. And therefore, even for example, if you have now communication with the mobile phone, it's the same like our Zoom recording here. This data is transferred automatically into text, right, with natural language processing. That is AI. And that is what also can be used later. That's maybe not for the initial reaction, but then for using it later to analyze what happened here and what can we do better next time. And this is where event streaming is the data hub to, on the one side, send the alert to the right person or system in real time, but then also allow other consumers to consume the data later. And part of that can be, for example, a data scientist that takes all the historical data from a site and then analyzes it with these AI tools for that. So I just would be very careful about talking too much about AI, because first of all, you need to set up the infrastructure, and then you need to set up the pipeline, the software for the data hub, and then you can talk about AI on top of that. It's not the other way around, because that will fail.
Right. Okay. And so without with all this interconnectedness and also the a lot of these places where they can't get connections as well, are you seeing also with the proliferation of 5G out there as well, is that actually solving a lot of that problem out there? Do you still need a lot of these edge devices out there, or will 5G solve a lot of these connectivity issues and you could just simply push things to the cloud? I guess I could pop that to Kai first. Yeah.
Let's talk about this. So we are the software side, right? And from my side, this is two very different topics. So 5G cannot solve every problem. It's great for many use cases, like you can do network slicing and can guarantee specific networks. But nevertheless, there is so many use cases, especially in these industries like mining and oil and gas. We are also always talking about safety and mission critical systems. In many cases, it's air-gapped environments. So you do not want or even cannot connect to the internet due to compliance reasons and security. And therefore, in these cases, you need to do edge computing. And with that, 5G doesn't help that much. In some cases, you can set up your own 5G private campus, but there is many different options about how you set this up. And in many cases, even here, if you have your private 5G campus, then still it often has to be completely disconnected from the internet, where you have your cloud data centers. And then we're talking about unidirectional gateways to connect between the disconnected world and between the internet. So the key message here is there's many options for the architecture from a software perspective, and it really depends on your SLIs and compliance requirements. And based on that, then you can think about where and how to process the data. And then in addition to that, we are talking about low latency requirements, then it's at the edge anyway. And on the other side, again, also about cost, because it's simply in all of these edge use cases, it doesn't make sense to replicate all the data to the cloud or data center. It's too much data. In the beginning, often this is not a problem when you start your pilot, because you just connect a few machines or vehicles. But then when you add more and more to them, and all of them get connected in the future, then there's too much high volume to send all of that to the cloud. So what we are doing here is typically at the edge, process the data and pre-filter it, and then only replicate relevant data to the cloud. Or then in the advanced use cases, we train the analytic models in the cloud based on the aggregated data from different sites. But then the model deployment or business rules are deployed back to the edge, because you want to do it in low latency in an air-gapped environment. And so this is the software perspective. But I assume, Dion, from the hardware perspective and infrastructure, there's also several pieces you have to take a look here.
Fantastic. That's a good explanation there. Dion, I saw you were going to say something about that too before.
Yeah, I think you're right. I mean, 5G is certainly not the answer to everything, and you still have some real world limitations. You need a cell tower, and they're not everywhere. And the other point I'd like to pull out is that contextual awareness, and you're right about being able to make decisions at the front edge, and to be able to do that, you need some form of local awareness. And so almost having a satellite sort of data pool where you can make some bit more intelligent decisions. So the classic one that comes instantly to mind, to try and keep it practical, is if you've got, say, gas sensors on a vehicle, and suddenly that says, hey, the gas is too high, this is going to be an explosive situation, and you're disconnected from the back end. You need a real way to tell people in a very, very quickly and a guaranteed way that, hey, there is trouble brewing, you need to react. And so having that localized decision-making process, but actually having the power of it back end, and to analyze all of that data after the fact is immensely useful for an organization, I feel.
Fantastic. Yeah, that's the cases you talk about are very much life impacting use cases there as well, right? This is life or death when you're talking about these edge use cases. It could be emergency services, it could be defense, anything like that. So very critical pieces there as well. You mentioned ITs and sensors, and that kind of brings me to think about another area we play in as well, and I think that you guys do as well. And that's in the logistics and supply chain side of things, that's and manufacturing as well. I assume that your radios and communications would also be used in, I guess, in those areas as well. It wouldn't be as mission critical, or I guess life-threatening in some cases there as well. But in sometimes they would be. But is that something that you guys deal with too, and see an application like this being put in place, like something in real time and communications there?
Yeah, so if I think about our own environment at Tait, right, because we are a manufacturing house, we do develop and design and manufacture our own products in Christchurch, New Zealand. I mean, our own teams on the factory use the radio to communicate amongst themselves on a daily basis, find out where people are. We probably don't use it so much as an analytics type tool, to be fair. But I mean, there's no reason why we couldn't extend into that. As if, I guess, if we got, significantly bigger, then the need to know where stock is in real time becomes more problematic, right? I mean, we're fortunate enough that we have a fairly slick, lean-based system to help us with that. But even then, they're radios. We can have barcode scanners on those. They have some trains that go around to refill the lines on a sort of on a 10-minute basis, for example, and being able to know where the guys are as they move around. If a job needs to be done to quickly refill some stock for some particular reason, having some IoT at the edge is certainly very, very helpful, and to speed things up in terms of the manufacturing capability of our plants.
Yeah, sure. And Kai, you're seeing some of that as well, right? I've seen some of the stories you publish in the manufacturing and supply chain.
Yeah, absolutely. I mean, the great thing here is, in the end, from our side, we really have the flexibility to provide every architecture the customer needs, and we really see everything. And it doesn't depend on the enterprise size, but depends on the current status of the customer. What do they already have in place? How much IT do they have in the factory, for example? So we see customers that deploy event streaming close to the production line. This is for predictive maintenance. This is for quality assurance, where we even process images, for example. This is things that doesn't make sense to replicate that to a data center or cloud first. And also often it's for low latency, where you have to process millions of events per second at the production line. So this is clearly running at the edge. On the other side, we see a clear trend that many of the supply chain use cases are also deployed to the cloud, because here you're elastic, you're flexible, you can onboard more and more machines and services. So if you have a good internet connectivity, and if it's not safety critical and all of the cybersecurity stuff is okay for you, then also we see the clear trend that these kind of systems are running more and more in the cloud. And this is also the trend we see from the vendors, right? So many ERP systems that you buy are running completely in the cloud, because that's the benefit for the customer. You don't have to operate it. On the other side, for MES systems, the question is, does it make more sense in the cloud, or should I have it close to my production line? It depends on so many factors, but most of the vendors also go into both directions, but the clear trend is cloud first, because it makes so many things so much easier. And the other interesting note here is that we're also not just working with the manufacturers here, but also with these kind of software vendors. Like the next next generation MES or ERP system of many of our customers is also going to the cloud. And these vendors have the same challenges that the end customer has. They have to process higher volumes of data in real time, reliably, and so on. And they also have to replicate it across regions and countries. And therefore, many of them are also powered by Confluent for exactly this reason. And therefore, the clear trend is really more a hybrid approach so that you can deploy it where you need to do it.
I just want to add to that. I think that's a good point that Kai had brought in. The way I see it for the mining customers that I'm dealing today with, they don't want to do any cloud solution. The reason they don't want to do anything on cloud is because they just don't have the connectivity in areas where they're doing exploration, where they're doing mining. So they prefer to do everything on the edge. And some of the things that they like to do today on the edge is autonomous trucks, for example, taking the mine from where they have dug it all the way to the depot. And from there, it's transported to the rest of the world. So autonomous trucks are something that use a fair bit of edge computing because A, they need to know where the other autonomous trucks are. B, they need to know the speed. C, they need to know their location information. And they have these wide different types of video cameras all around the trucks and doing a bit of video analytics, data analytics, taking decisions at the edge rather than sending something on the cloud and having a round trip delay of around a couple of milliseconds or maybe even a couple of seconds is not affordable for mine trucks. And they see more of autonomous implementation here in Australia. And this actually has proved to be more efficient because rather than having someone centrally control it or having intelligence done in cloud, doing everything locally proves a bit more efficient for the mining customers. So I see more and more of mining customers going autonomous using edge computing. And that's where I feel event streaming could be a fair bit beneficial.
Yes, and maybe to add to that, because we really see this discussion all the time, as you said. So, in the end, we see three kind of environments where customers deploy our technology. On the one side, it's in the cloud. This is elastic, scalable, like crazy. Then it's more like at the edge, but still in some kind of room where there's a few computers, right? But then even at the last mile of the edge, like in a truck. And that's also what we see where then often it's not even a cluster, but really a single computer with a single node of Kafka, because then you can still collect all the sensors from the truck and you have it on the road. It's disconnected from everything for 10 hours, but still you can collect all the data, what's happening there about the temperature and everything else you need to do there. And then when this vehicle comes back into the station where the computer room is, then it has a very good internet connectivity for, let's say, an hour because you're getting new fuel. And then you're replicating all the data in this hour to the computer room. And then you go back for 10 hours where you're disconnected. And this is also part of our technology where we do this kind of replication. And the benefit why people are doing this at the last mile in the truck is that with one single platform, you can do not just the real-time messaging and streaming, but you also can store the data because Kafka is also a storage under the hood. And you can do the data integration to the sensors that are running in the truck. And also another last point here to clarify, however, is we are really an IT system, right? We are not an OT system. So we are not talking about embedded systems, for example. So when you mention the autonomous truck, the autonomous communication, that's typically things like in C or embedded software, right? So that's not Kafka, also to clarify. We integrate with these kind of systems like with car IT or with robots, with ROS or so, or with machines with PLCs. But that's in the end also where we have the interface. So we do the IT part even in a truck at the edge, but the OT world, that's separated. And that's other technology that's much closer to the edge and often proprietary and really embedded system with hard real time, for example.
Which is kind of, by the sounds of it, where Tait plays a part as well. And so where do you see, especially in that mining scenario there, Sohan, with the radios or any sort of communications you have with those trucks there? I mean, where do you see this play a part in this ecosystem?
I mean, today mostly what the customers use overhead or overground mining is digital mobile radio, DMR radio that works on a 400 to 430 megahertz frequency, and it's mostly for voice comms. So you may have a miner in a semi-autonomous truck or a manual-driven truck, and if they want to do a voice comms, just to let the other truckies or the dispatch console know where they are, they use a portable radio and do a voice comms. But with autonomous trucks, what I've seen is it's you don't have anyone basically driving it. It's all done automated and there's no voice comms whatsoever. For example, we are trying to position a unified vehicle. Unified vehicle is a combination of DMR and LTE. So what it does today is if you are on a DMR network, digital mobile radio, and you don't have DMR connection, the system automatically using state-of-the-art algorithms fails over to an LTE network. And we are trying to do that also for the data side, not only for the voice part of it. And so having done a fair bit on mining and having implemented this voice comms, we see that our customers still want to stick to voice because they say voice is important. If we lose LTE connection, for example, or if we use any other forms of comms, we lose data completely. So voice is something that has been robust for the past 50 to 60 years, has proven technology and still being used a fair bit today in the mining customers. But that said, they want to try to do a bit more autonomy, not only in mining trucks, but also in their small scale vehicles, which they use to sit down to go from point A to point B. Recently, when I visited Newcrest Cardia Mining here in Australia, I noticed that they have these Toyota vehicles, and these Toyota vehicles, they sit, which is not driven by petrol or diesel. It's actually electrical vehicles, and the person had to do nothing. All he had to do was just use his finger, start the car, and it would just go on 20 to 30 kilometers without him using the steering wheel. So this level of intelligence is starting to be used not only in trying to get minerals from point A to point B, but also in these day-to-day operational activities. But to add to what you said, voice is still important. And even though I see a data exploration and having intelligence at the end and doing a lot of data processing at the end, I don't think voice is going to go anywhere in near future.
Yeah, right. Fantastic. That's a lot to unpack there actually, and it's good points you bring up because voice will always be a part of it as well, regardless. But with the automated vehicles, you can imagine like they've got GPS sensors and everything like that there. You've just got a proliferation of data points for them to be operating there. So on that front there, before we tie it up, I guess, where do you suggest the audience to go, I guess, in this front here? I mean, with so many data points, so many things to consider as well, and data management skills required, what do you see as a first step in your eyes?
Well, for me, as basically, they need to see really what they need from a use case point of view. It all starts with the requirement, whether they really need edge processing or edge computing at this stage, or whether they're happy basically with cloud. Now you have something else that comes into fog computing, cloud computing, fog computing, edge computing. So fog sits in between you. It's really not at the edge. It's not closer to the cloud computing environment, or neither close to the edge. But that's where you start using fog computing processing to basically do a bit of data processing. My test for the audience would be, know what you need, understand your requirements, and see if edge really solves one of your problems today, or you can really use the services that are in cloud. But the way I see things going forward with the explosion in IoT devices and the amount of data that's being produced today, I see in another, just like Gartner says, 75% of the industry around the world by 2038 is going to be quite reliant on the edge. And that is not only doing processing at the edge, but doing a bit of event streaming at the edge. The way I see event streaming could be possibly, if there's an alarm, what do? Do I send it back to a control center and have that control center officer, do a pan tilt and zoom to the nearest camera to see what's happening, where is that event location, for example, or let me take the decision using a bit of intelligence at the edge and close all the gates, alert a siren, and let people know that there's a disaster. So to start with, it always starts with your requirements, and then you have to analyze the benefits of the edge versus the benefits of the cloud, and where you really can position where your business sits today and your requirements are well addressed.
Yeah, and maybe to add to that from the software perspective, I totally agree to what all you said. The point is really, most of our customers, they think about the business problems first, of course, but then also they have to think in steps how to implement this. So most of our customers are very happy in a first step if they just can connect to a few of the sensors in a pilot project from the vehicles or machines, and then build a dashboard on top of that. That's the typical number one use case I see. And after that, they can go into two directions. They can either connect more and more systems, that's what's typically happening, so that they can consume all the sensors. And the other part is that you can then correlate the data and define business rules of what do there. And here again, often customers start very simple because sensor data is high volume. So they first process it, and that means they filter it, they aggregate it, and they only show the relevant numbers on a dashboard, or maybe even a threshold to send an alert if a temperature is too high over 10 minutes time span or so. That's traditional stream processing, even for very simple use cases, and it's very easy to implement. And then after you have done all that, then you can think about the cutting edge fancy things like machine learning and AI and natural language processing, all these other systems you can do, because and technically it's possible, but it's a tough project because all these data sources are different. It's data integration first, and after that you can build AI on top of that, right? And this is the right approach and how our customers typically do it. And this can take a few years, and that's okay, but you start with the data pipeline first, build a dashboard, build a few simple rules, and then decide based on that if that works, and then expand. Or maybe if you then re-architect, because as just said, maybe then you find out, well, just replicating all of that into the cloud, that's not our solution. We need to do real edge computing because we need low latency for some of the use cases, right? And that's why we also see, just to give you one example, we're working closely with AWS and their wavelength team. So that's wavelength team, that's about 5G with the telco providers. And here it's exactly this discussion we have with customers. Some of the use cases need low latency and some others don't. So the low latency is always more expensive typically. So we need to find out from a customer perspective, what do we not need to do there? And this is an ongoing basis, and it's totally okay to fail in a pilot and then re-architect to make a different decision. That you, for example, true edge computing because of the low latency or security requirements. And this is how we see it our customers, and this is a successful way they are doing this over the last years.
And just to add to that, I think Kai touched on some very, very important points. And the way I see it, the audience need to consider a few things. One is your bandwidth. You know, it's the amount of data today which the network can carry. So does your existing network have enough of bandwidth basically to do what you want? The other is latency, is basically the time needed to send one data packet between two different points. The other is your round trip time, is basically sending something back, the server getting that information, processing that information, sending an acknowledgement back, or sending what needs to be done next. So if your end users say, I'm fine with the bandwidth, I'm okay, I don't care, there's no heavy end data that's being sent today. Latency, I don't care, it's not mission critical. Round trip time, I can manage 5 to 10 seconds, doesn't matter. And then is edge computing really important for such a scenario? I would say maybe not. But then you're taking it a step ahead where you're saying, let's start using driverless cars. Then can you do things at the cloud where you have your bandwidth is pathetic, latency is bad, round trip time is a disaster. So in this case, then I would say no, because your lives matter. You don't want your driverless cars going and killing people and dashing all around. So there you need state-of-the-art computing processing at the edge with good intelligent software that does things preventing accidents and other disasters.
Yeah, some really good points there. And so what's next in terms of for Tait there? I guess with your existing customers in this field, you've got radios out there already, you've got a large base of customers. Where do you see their next step in this journey for them? Can they just simply upgrade their current radio systems? I know this sounds very rudimentary, and I guess for a guy that's not in this industry, what do they do from here to get them to this point?
For public safety, and then maybe Dion, you can jump in and add in for the other customers. We've been getting a fair bit of request on video analytics, intelligent video facial recognition. And the customers are coming to us and they said, you do good in voice, but we would also like to see you guys removing noise using algorithms like AI, ML, and that's all great. But we're starting to see more of video, especially citywide surveillance. And now with all these protests and terrorism activities, customers are coming to us and saying, we have these old traditional cameras that basically send video feed on an LTE network or on a fiber comms back to a control center where you have 2 or more people sitting down and having a look at the video 24/7. And that doesn't work because, human eye has a very short concentration span. You can't be sitting like this and keep looking at who's the bad guy out there. And they say we have started to implement technology where we start doing facial recognition. We know who's the bad guy. We feed the algorithm with a picture of a bad guy, and bang, it suddenly alerts us. It may not be accurate, but still we get some kind of indication, and then we can follow through. But now we've been asked by our customers, how can we do things at the edge? If there's a missing child, and if we know a picture of a terrorist or a bad guy, how can we feed that edge computing device with the missing child? And the system is 24/7 looking at thousands of people, scanning the face of these thousands of people. How can we get an alert then and there rather than having things, done at the cloud, or have someone sitting and looking at a video feed 24/7? So these are a few things that our customers are starting to ask us. And also in fire services, they're looking for vehicle as a node, but that vehicle as a node needs to be intelligent, where it does comms, where it does data processing, where it does event streaming, and also has the ability to send data, if needed, back in the cloud for storage.
Wow, what an impactful use case. Wow, that's crazy.
Yeah. If I can add to that, in another sector is transportation, right? And so you've got massive trucks on the road. There's a significant amount of money tied up in that vehicle. Having it off the road is money lost. So you're wanting to know what the truck is doing, but also the other spin on this is the health and safety side of it, particularly in New Zealand. Managers and at the top highest level are responsible and by law for what's going on in their staff, and so they're wanting to do things like monitoring their drivers. So what they're wanting to do is take the data from how they're driving the truck, and even things like, are their eyes starting to droop a bit? Are they starting to act tired? And using all of the analytics from the video world, from the truck performance, and gathering that together and doing some pretty cool analytics on that to make some real cool decisions around, hey mate, I reckon you need to take a break, because you're heading down a path that's not good for you. So there's some real world life decisions, and then where does that decision get made? There's an element of, does it get done on the truck? Is it a combination of in the back office with the back end systems? And the answer probably lies in between there somewhere. But having the capability at both ends, we can adapt. And I think the thing I'm finding with the whole IoT, it's 3 letters, but it may as well be an alphabet. And some people look at it and they go, well, I don't know, I get it, but I don't get it, and I don't know what I can actually do. So they do a pilot, and you guys touched on it before, it fails or it doesn't quite meet the need. But the thing I'm finding is people don't want to be backed into a corner where they can't expand their system and add to it as they get really fired up and excited, and as their mind starts to spin on what they can save in terms of productivity and gains for the bottom line. And all of these things are real world challenges that I'm seeing some of our customers in the tech space are needing and demanding they resolve.
And go on, Kai, sorry.
And maybe to add to that story, because we're now talking also about the connected vehicles, the interesting part is, so with Confluent, we're doing this for many years. Typically, they started around 5 years ago, where the first premium OEMs have built a connected car infrastructure, and then they rolled it out across the globe. The good news is, for these industries like mining or oil and gas, it's actually much easier, because you don't have to connect to 10 million cars, but maybe to 1,000 or a few thousand, right, vehicles. So this is much less challenges actually, and we also have to experience already how to do that. So this is really not that hard to do anymore, and the technologies are there. In this case, of course, it's not just event streaming, right? Like typically you use MQTT for the communication to the vehicle if you're on the street, because it was built for bad networks and for connecting to thousands of machines or vehicles. But in the end, this is the end-to-end story. And if you think about oil and gas, the story is not stopping when you have the upstream done, right? It's about midstream, it's about downstream. And the funny thing then is, again, when we go back to the downstream, to the gas stations, this is again where more and more customers and enterprises think about edge computing, because yes, in the end, you just want to get the oil, right? But on the other side, you want to do a better customer experience. You want to build a loyalty system. You want to have after sales and all these things. That's, by the way, the first use case we have seen in the connected car infrastructure at the OEMs. It was not about maintenance or predictive maintenance. It was about after sales, so that you have a better connection to end user. And in this case, it can be the customer, the end customer in the gas station, or as you just explained, it can be the driver in the truck. So this is really important. And the last part here, and that's also interesting, when everybody's talking about analyzing the driving of the truck and so on, this gets even more challenging in many countries. Like in Germany, people are very resistant to that, and the law doesn't allow this because you don't want to monitor the people. But this is still possible, even with GDPR compliance. So did you monitor the data in the right way without having privacy information about the driver? And this is also where we help, because you can consume all the events about how the truck is driving, but that nobody sees the data for a specific person. You can only send the aggregated data to a management person so that he can learn in general how you can improve the routes in the driving process. But it's not allowed in Germany, for example, that a manager sees that one specific driver is not driving well. This is not legal in Germany. But this all of shows, right, that this kind of privacy issues combined with the data correlation, but still it's solvable depending on the country, right? You can implement whatever is and do it the right way.
And you're absolutely right, and we're very aware of that space. We have a security team who, and in fact, this week we were talking about just what you're talking about, actually, and talking about making sure that our products do comply and that we haven't inadvertently put in someone's private data. So we see it as massively significant, that whole privacy space, for sure. I mean, I don't think in New Zealand we're quite nailed down on that front yet, but I'm sure it's only a matter of time. But I hear some excellent points.
Fantastic. Well, and Sohan, you wanted to say something just before Kai as well?
Oh well, yes. What was I? Yeah, this was just one of the use cases, a request from the customers that we had recently, and maybe Confluent would be having a solution with us, where we see maybe a joint venture between our company and your company. I know we talk about edge computing mostly related to data, but so is voice. Voice is a form of data because it is on a data packet at the end of the day. Yeah. So one of few of the things that our customers are asking us, and these are the young coppers out there who are like, when we go and stop some people, they are drunk. We ask for their license, and then we go and do a license plate check, and all that is great. But we are connected offices. We have a radio speaker mic over here. We have a body-worn camera over here. We have a portable radio from Tait, and we are like these robo-cops. So how about building something for us where we could understand, do a bit of sentiment analysis on the person who we are having a conversation. Maybe they busted a drug lord and he must have said, hey, how are you doing? And, from a voice point of view, as the officer starts to quiz this person, the guy starts to get nervous. Now, not all humans are good judges of voice. Some are and some aren't. But how about using technology at the edge to say, okay, this person is a bit nervous. I can sense danger, so be on an alert. But again, I see that you need to use some level of event streaming over there, because you're analyzing that person's voice. You're trying to say, okay, he from a very happy, voice tone, he's become sad, or he's in a very angry state. So beware, get ready to, take out your gun.
Maybe also add even more context to this about when we hear about voice, which in the end is digital today, right? So voice is not analog anymore in most cases. It's digital.
That's right. Yes.
And the same is true for videos, right? When we talked about the security cameras and so on. And therefore, can you give you one more example from our customer base? So Netflix, which is one of the biggest video streaming services, right? They are not streaming the videos via Kafka. You could technically do that, not at that volume, at lower volume. But of course, they use the content delivery networks for the video streaming. But they are still one of the biggest Kafka users on the planet. And why are they that? So the reason is because they process all the metadata. And again, for privacy reasons, often you're not even allowed to analyze the voice itself, even if it's translated to text with NLP. But even if you just use the metadata, it's so powerful to analyze many different circumstances. And that's exactly what Netflix is doing, for example, for building a recommendation engine based on the metadata, send the right context-specific information to everybody. And the metadata is so powerful, and still it's legal, because that's how WhatsApp is working. WhatsApp is end-to-end encrypted, but still WhatsApp knows everything about you, because they know who you're talking to and when you're talking talking to them. And with that, they will find out everything even without reading the messages. And this is a little bit also important to understand often with event streaming, even if it's voice that is processed by a specific voice processing tool, and the same for video, still the metadata is super important. And that's also what the decisions are made on, and how the data is routed and where it's stored. And this is often where event streaming is then combined with other voice or video streaming technologies.
Fantastic, guys. I love it. That's amazing. I actually, I watched border security the other day, and this actually plays a very good part in it. Actually, there was a guy that was nervous while he was talking, and he was at the gate and everything like that, and they thought, oh yeah, he looks very suspicious. But something like this being put in place, being able to judge the sentiment just off facts, would be pretty powerful as well. So not just police or anything like that, you're talking about border security, anything related to human interaction, really. So yeah, really cool use cases. I love all the discussion. I love the ideas here as well. We've hit the top of the hour though, so I'm going to give you guys some time back, but I really appreciate your time. Thank you everyone for joining today. I'll make this webinar available after this as well. But again, it was a really good discussion. I love the topics that we covered as well. Hopefully we can do it again, and I'm looking forward to a great partnership between the two of us.
Brilliant.
Okay.
Thank you so much for your time.
We look forward to the same, because we've been exploring your website. We've been seeing some of the webinars from Kai and the rest of your team, and we are quite impressed at what Confluent has done. And that excited us, and so much so that we went ahead and tried to deploy Apache Kafka on my small little Raspberry Pi.
Awesome. I saw that video that you posted the other day too, so fantastic. We're really looking forward to it.
The future is great. The future is great for edge computing and event streaming. That's for sure.
Beautiful. Thank you, guys. Thank you so much.